Now what happens if our solid of revolution is given by turning our function around the y-axis instead of the x-axis? Now you realize that at each point here, instead of having like before these sections that are circles, right? What we have is, if you take a partition, right, of this between, you know, xi and xi plus 1, right? We have this. You turn it around, right? What you have is cylinder, right? You have the I don't know how to plot this correctly. Why? Suppose think of it from the outside, right? So you have this is the y-axis, right? And this is the x-axis, right? So you have this, you're turning around this, and this is your point xi plus 1. This is your point xi. Now in this here, you have this area, which is the area of the cylinder, and now you have to subtract the area of this smaller cylinder to get the area of this thing, right? So what we add in here are not sections. We're not adding how to say this, rectangles anymore. We're adding cylinders, right? So if we add the next cylinder with given, you know, whatever is this area, right, or the volume of this, right, this is the next cylinder that we're adding, right? This is xi plus 2, right? You see, right? So you're going from here to here, and at each partition, each interval, what you're doing is you're adding a cylinder, right? The smallest cylinder, the highest cylinder. How do you compute the area of a cylinder? Well, the area of a cylinder is given by pi. Sorry, the volume of a cylinder is given by pi times the radius squared. So in this case, the radius is xi squared, and then times the height at that point, which is f at xi, right? So the difference between these two, the volume of this hollow cylinder is given by this formula, pi xi squared minus xi minus 1 squared, right? F at ci, right? So you're subtracting the area of, the volume of the cylinder, the outer cylinder, from this, you're subtracting the volume of the smaller cylinder. Okay, so you can sum this from I equals 1 to n, and you get this, right? And where c sub I here is a point, any point that's between this, right? It could be, this is the the Riemann sum, right, that we had done. Any point ci belongs to this interval xi minus 1 xi, right? This is closed. Okay, now when we take the limit, we get to the integral, but in order to get the limit, what you need to do is get an xi minus 1 in this formula, right? Remember what we have done with Riemann sums before. But here, you can do this like this. This is the difference of the squares. This is the same as the difference of the reciprocals, right? Now, this formula is valid for any ci, because this is bounded by the maximum and minimum values here in this interval, right? Using any of this Riemann thinking that we have been doing. But this in particular, this is valid if we take ci as the midpoint of the segment. Okay, so xi plus xi minus 1 divided by 2, that's the midpoint. Okay, so we can rewrite this as 2 times ci. So this formula becomes from I equals 1 to n of 2 pi ci fci xi minus x minus 1. Okay, so when we take the limit with this very small partition, this thing disappears, and what we're integrating is this formula. Okay, so the volume of a solid of revolution around the y-axis is given by the integral between a and b of 2 pi x f of x dx. That's the formula. Okay, and it would be maybe easier if we would think of this function in terms of y, but if you don't have that, you can use this formula. Okay.